So welcome back, CIS 123. This is week 5, and today we're going to continue talk about pointer strings arrays. That's just for the warm-up, and then hopefully we can also discuss further discuss the project structure, further discuss the projects with perhaps multiple files, multiple header files, multiple source files. So we'll see how this progress we can make during today. This is the latest update, October 9th. So basically we're officially week 9. I hope you're keeping up with the reading, the textbook, and the textbook chapters are posted, the pages are posted. I'm expecting that you should be trying examples from the book on your own and seeing if it works or doesn't work. So that's something definitely on our agenda. All right, so moving on. Like I told you, a few things for the warm-up. Since you guys have the Visual Studio installed in this classroom, you can follow along. So today I'll try using my Visual Studio compiler as opposed to code blocks. Later on, after break, we can switch over to code blocks. But since you have this on your desktops in the classroom, I would like to try using Visual Studio. I will create a new project, and you can do the same thing. File, new project. It's very similar across multiple integrated development environments. So just say new project, same thing in code. And we will just work with a small set of examples today to begin with. The usual, when you make this, when you see this wizard screen, number one, make sure you select C++. And number two, make sure that you select empty project, because that's usually how I begin my projects. I will name my project down here as week 05 demo, and we can make progress off of that. I usually uncheck these. I don't need those. Additional directories or additional configuration options. Hopefully when I click OK, this will be pretty much the end of the configuration of this project, right? So very simple start. Again, in code blocks, we did this last week. I did the same thing in code blocks. It's put on record. You can see it on YouTube. All right, so usually it takes a little bit of time to configure everything. You should see this status bar messages. Still says here creating project, and it says successful. So if it's telling you that it's doing something, then maybe you should wait a little longer, because you want this to be ready. The next step to do is to say view. In code blocks, it's a view. I forgot the option. View. I think manager. Over here is View Solution Explorer. So both windows give you access to the structure of your project. You can see that in Visual Studio you can have different types of items like this: external dependencies, header files, resource files, and source files. So for the minimum amount of configuration, you only need the source files, because header files, which perhaps will be part of our discussion today, you only need for complex projects where you want the environment to help you out, like browsing through your source code. With the minimum amount of work required is just the source files. What else is on this list? External dependencies. When you include like third-party libraries, you can also make it quicker to search through source code when you have dependencies listed here, where we absolutely do not need this section. And resource files are pretty much anything except the code that you want to make it part of your executable image. For example, you can include bitmap files directly inside the image, the executable file that you will create in this project. Then you can include those bitmaps directly to the list of resource files, and then you can reference them, and the compiler will know that they need to be included as part of your, say, global data in your program. So again, we don't need this. The only thing that we do need is the source files, and if you right-click, you can see, you can say add, and in our case, we don't have any source files, so it's just going to say new item, and it's supposed to open a wizard like this. And we need to select Visual C++ section again, and here you can see that C++ file.cpp is the one that we want to create. I routinely name my first source file in any project main.cpp because I know that I need main function. And then, of course, as before, as in code blocks and here as well, I will add src, the source subdirectory, to place my own source files in a subdirectory like src, which I just typed, so that I can easily locate my stuff in there. And I can just say add, and it's supposed to open it in the code window. So let's just test things real quick. Include IO stream. I will use C++ output because that's what I normally use, and it's very simple to use. A main, of course, it should return an integer back, right? And this is a function that doesn't take any parameters. Let me resize my font so you can see what I'm typing, and close this silly window, and close this because I don't think I need to often to open the Solution Explorer to look at. Right, so main, and in its body, we can have, remember I told you that I normally end all of my source files with an empty line. It's a long-standing requirement since the days of C, like since 1970s, that it's part of basically code of conduct, if you will, to end the source files with empty line. And then here I will say, of course, return 0, which signals a successful termination of the program. And then I will say something like std cout print hello, right? Print hello like this. And I can even add like new line in the same string. And of course, add the semicolon. This is a statement in our programming language. If I save this, I can click build and say build. Right, so it builds. You should watch out that it doesn't give you any error messages. Usually I look at the very bottom of this first and just say, oh, okay, one build succeeded, this is fine. And then we can say debug and start debugging, or start without debugging. Let me first try it without debugging. I run it. You can see real quick the window flashes and disappears. It's because the program doesn't have any input, doesn't have to wait for anything. It just prints like 6 characters on the screen and exits. So that's why we need to kind of stop it. And I think we can do this. We can say include cstdlib. And then once we do that, we can, before we return, we can say system pause, right? We can invoke shell command pause, and this is going to be standard on all operating systems and platforms, and it should be a pretty nice way to, prevent our window from disappearing. Of course, I need to build again after making a change. Of course, I need to run again to see what's going on, and here's my window. I normally go here and click Properties, and first of all, in the options, I normally select Quick Edit Mode, which allows us to copy and paste from inside the command window, this window. And then for us to see it easier, I will modify things up a little bit to just make it a little bit more larger font, I guess, and then the layout or colors rather, we'll make it something like this. Okay, so this is fine. So you can see my hello gets printed and the program works. Okay, so let's discuss a few things. Number one, what we have talked about was this, that hello, this string right here, let's pretend that this is some kind of a message, MSG, right? So for me to pass this message as a variable to my standard output device, which is represented by this stdc out object, I need to somehow configure it. MSG equals hello, right? And by saying configure, I mean that if I want to have a variable which I would like to basically keep track of my string, I need to declare it, right? And we already said that what any double-quoted string in C and C++ returns is an address of the first character H in our case. We have pointers that retain which are variables to retain addresses, and we can declare it as char pointer, right? Message equals hello. Okay, so what we have here is basically just a quick reminder, is that when we, if we try to draw things up, basically what happens is that, of course, once again, I'll go back to draw like program in memory like this, and somewhere here we have a set of we have a global variable section or segment of memory, and somewhere here we have this hello string located, and of course when we declare a message, this is our pointer, so it's somewhere in the main function stack frame, right? So this is stack memory segment at the top of our program, and we have this message, and it contains the address of the first character, just like this, right? So we have a pointer named message, which points to hello. We discussed this last week. If you would like to refresh your memory, we know that this is what we get in terms of looking at our memory.